All right. So, first of all, you should probably meet all of our teachers. We have four, technically. So, first off, me, I'm Snug. I'm a creator in Rec Room, and I do circuits and like studio and stuff. All right.
All right, I'm a Ducky. Been doing circuits since they came out, so I'm pretty knowledgeable in that. I'm also a creator that does circuits. I do building too, but I prefer circuits.
Yeah. Do man, turn up your mic. Also, as Ducky was saying, he builds. He built this entire classroom. So, props to him.
A little bit old.
Yeah. All right. So let's get started. Uh, so raise of hands. Who knows nothing about circuits? Like you know that they exist, but you don't know how to use them at all, and it's totally fine if you don't. This is a circuit class, so yeah. All right. Who thinks that they're like, you're kind of good. You can make like a light turn on and off or something, you know? All right. Um, I think a quicker way to do this from a scale of 1 to 10. How good do you think you are? Type that in chat. We'll get an average.
Up on 1, 9, I guess 3.
We got a 9. Why are you in a basic circuit class?
Oh,
All right.
he's the one
I
who
already
said
explained this
he
in
always
my
wants to
Discord.
learn new
Oh, he's
things.
the one from the. Yeah.
Yeah,
Okay.
I explained
All
that
right.
to
So
you.
we're all about like in the middle-ish. That's pretty good. So in this first class, we're going to be going over very simple stuff. So some of you said that you don't know a lot. So we're going to show you what you're missing, and to the people who already know, you're just going to have to sit through it, I guess. But hopefully you learned something you didn't know. All right. So let's start with these. These are all of the ports in Rec Room, and most of the ports in Rec Room. Uh, Here is the most important port, the execution port. The execution port is how you will run any circuit. Think of it as like power for your circuits, right? Uh, Without power, you can't do anything. So keep this in mind because that is a important port. Um, this is a boolean. Booleans simply just give you a true or false statement. So you can have a boolean either be true or false, and there's no in between. It can't be like letters or numbers or anything. This is a integer, the green one right here. An integer is a whole number, not decimals or nothing. So a whole number, and this is a float, the blue one, and that is a number with decimals. So you can go into decimals if you wanted. And then this is a string. This lets you do stuff with text. So like all of our names, all of our usernames is a string because it's text. But something like 64, while that could be text, you'd probably want to make it a integer. Depends on what you're using it for, and we'll go more into that. Will, do you want to do the other side?
Yeah, so here we have a vector. This is just a three-dimensional float, basically, which might sound kind of complicated, but basically, if you have a float, this is just some decimal number. You can think of it as a number on a number line. So going from negative, really small number, you could just think of it as negative infinity up to positive infinity. It's just somewhere on that line. A vector 3 is you take that line and you do it in 3 dimensions. So just like space, like you could have a coordinate. So you go like x, y, and z. That's actually what each of the components of the vector is. They're x, y, and z. And you can do lots of things with vectors. You can represent rotations or distances or coordinates. We use that a lot for physics, which we'll get to later in the class. Right here, we have the Rec Room object type. As the name implies, this is just an object that you have in Rec Room. Really, anything that you have that you can interact with circuits. I think it's literally anything other than like studio objects, which don't really matter here. So if I like spawned in like a basketball or something, that would be a Rec Room object. You usually get these either with tags or if they have an object board. Like if I were to spawn in a button, you'd see a little board above it. There's a little self port. I can actually show you this to make it a little clearer. So the button is a type of component, which is what they're called. Just like components are just things that you interact with in circuits. So this is the object board of the component. If you have it selected, there'll be a little like dotted line connecting them. And this port up here, this is called the self port. This will give you a reference to the Rec Room object. So if you want to say like, let's change the color of the, or let's change the text of the button. You get a button set text chip, and it takes in a port to tell you which button it is. So you'd use this port here. And yeah, that's like if you want to like manipulate objects or operate on them in any way. Below that is player. This one's pretty self-explanatory. It references a Rec Room player. There's a few things to be careful of. You should know that any player that has left the room will always show up as an invalid player. Like if I were to hover over this is just piping through the local player. It's like this literally says local player, which for me is me. For you, if you were to hover over this, it would say your name when you hover over it. So we'll get more into this in the future, but circuits is networked. So every player is going to have like their own version of what's going on, which is why when you hover over this, it can give you a different bit of text depending on your client. Something cool that the player type supports is that you can see a few of these have little default types, like a little block sticking outside the left on the input. This is just like the default value, which is pretty much what it sounds like. If like you don't have to wire it up to anything, it just has that value automatically. And you can use the wire tool or configure tool to click on it and set it to something else. The bool one is kind of cool. Like if I just click on it, it's changing between true and false automatically. The player port is kind of useful. It has similar functionality where it will default to local player, and if I click on it, it'll switch back to invalid player, back and forth. You probably won't need invalid player too much. And then next up we have color. This is, as you would expect, just a color you have in Rec Room. You can use these on a variety of chips. Like if I have text, if I respond to a text component, there's a text set color chip. So one of the inputs to that chip obviously is color. So like it says red right here. You can just configure it and pick color just like any other place you pick color in Rec Room. Just like if you were recoloring an object with the maker pen, it's just a regular color. There's a few chips to edit those. We'll get into those later. And lastly is a quaternion. The name probably sounds kind of like you probably haven't heard this before, maybe if you haven't dealt much with this kind of like math or physics. But basically what we use it for in Rec Room is just a rotation. So you can represent rotation with a vector 3 in some ways. Typically when we're doing math with rotations, we use quaternions. The implementation doesn't really matter. It's technically 4-dimensional. It's like a 4-dimensional value inside. Whereas vector 3 is 3-dimensional, but we typically use chips to just handle quaternions automatically.
All right. Also, we're not going to go over quaternions. That's why it's in red. So that's the most you'll hear about that. Ducky, do you want to go over variables?
All right. So you got all your variables here, and you notice they're complete copies of your ports. So you can save, which is what a variable is. You're just taking your data type, your port type, and just saving it into your variable. It takes your input, and that's what you're saving it. And this is your saved value, and that applies to all of your variables here. You can configure these and turn it into a synced cloud or the default, which is none. When you're on none like this, it's unsynced, and every player's variable can be different. Cloud will save across your instances or your subrooms. So if you wanted to have some sort of kill counter or something along those lines, you could save like an int or whatever. I don't know, I can't really think of any examples right now, but and synced is just every player's value be the same. So if I were to set my float variable to 1, all of your float variables would also be set to 1. Pretty easy and very useful. You'll use these a lot. How about it?
All right.
Think I forgot anything?
So now let's go over how to construct just like a simple circuit. Let me move these out of the way. And need this. There we go. All right. So to make any circuit in Rec Room, you need some sort of power source, like I was saying earlier with the execution port. And you'll notice all of these have these red ports going outwards because they're all like a source of power, right? So these are all different ways to interact with circuits. And the important thing about all of these is that they all have an event receiver inside of it. So all of these have event receivers because event receivers are how every single circuit that runs something starts. Does that make sense? So if you were to go inside of one of these boards by using your edit tool on your MakerPen, you can click on these boards and you'll see a bunch of chips inside. Doomman, if you want to do that, you can show it on the screen over there. What's inside of one of these boards. So you can see he's currently editing. I think that's the toggle button. And you can see there's 2 event receivers, and then there's some other chips that we'll go over. But it starts with an event. All of these have events in them because that's how every single circuit begins, right? So let's just start with like a button. Let me get. All right. So here we got a button, and there's 2 events on it. When I click press, this first one will go off, and when I release it, the second one will go off. There's not a really great way for you guys to visualize it. So I'll do something simple, like I'll grab a beacon. So here's a beacon. And you'll see there are inputs or imports on this beacon right there. So now if I connect the output of the button to the input of this beacon, I'll also do the release to the off of this beacon. Now, can anyone guess what's going to happen when I press the button? Feel free to raise your hand.
It will still turn on.
It'll turn on, and what will happen when I release it?
It will turn off.
Yeah, it'll turn off. So you see when I press it, it's already on, so it'll stay on. And now when I release, it turns off. So on and so forth. Every time I click it, it turns on and off. So that's a way to construct a super simple circuit just by connecting the execute ports. And yeah. All right. Will, I'm going to give it to you.
What's next on the list?
I guess we can move to Booleans.
Okay, so here is the main list of chips that you're ever going to want for any sort of Boolean logic or Boolean math. And as Snug was saying earlier, a bool is just short for Boolean. It's just a true or false value. So if you put down a chip, you can see there's this input port. It supports default values, just false or true. So here at the top, we just have a standard variable chip. This just stores a true or false value inside of it. As Ducky was saying, they just remember some value of that type. You can make it synced if you want, and other people will have the same value. So first here, we have OR. This kind of just does what you'd expect. If any of the input ports here is true, this will also be true. The only way this output will be false is if every single input port is false. Something you can do with the OR chip, which a few math chips support, is you can configure it with your configure tool, and you can add inputs. So you can see like it's physically actually getting longer, and I can remove them as well. I think you need, you need at least 2. Yeah, so that's OR. We have NOR. This is neither or. I think only one of them. No, it's both of them have to be false for it to be true.
Which
Is that
one?
true, Snug?
Which one?
Yeah.
NOR. It's like both false, right?
Nor, yeah, if they're
Only
both
one of
false,
them
it'll
have
be
to
true. If any of them are true, then I'll output false.
Cool. Yeah. And then we have exclusive OR, which is kind of similar. Only one of them can be true. So if both of them are true, well, that might return true on the regular OR chip. Both being true will return false on the exclusive OR. If they're both false, this actually will return true. Or wait, sorry, never mind. If the first one is true and the second one is false, or the first one is false and the second one is true, that will be true. Then we have not. This just takes a Boolean variable, a Boolean value, and it flips it. So there's only one input because that's all you need. It's considered a unary operator, just taking one value. So if you input false, it gives you true. If you input true, it gives you false. We have AND. This is kind of a counterpart to OR. The only way it will return true is if all of the inputs are also true. So like some of these other ones, you can configure it, add more ports. Every single input has to be true. We have NAND, which is not AND. It's logically identical to running something through an AND chip and then a NOT chip. We also have parse bool. This is actually this is like a member of a family of parse chips. Well, you give it a string. So this string is just any string type. So if you have a string is just a list of letters. So if your string says like the word true and you put it in, if you just try to use that string port that says true and you try to wire it here, it won't let you because that's not a bool port. But you want to convert it to a bool, so you use the parse bool chip, and it will parse it. If you put something else that isn't a bool, like if I put like will chill into it, the string, parse success would be false because you can't convert the string will chill into a bool. But if you put true into it, this output result will be true. If you put the string false, this output will be false. We have equals. This is one of the other chips that lets you configure it and add more ports. Basically, you give it a list of values, and if all of the values that you give it are identical, then this equals will be true. If any of them are different, then it will be false. So you'll notice these ports here are white. This means that it accepts actually any object, any type. So if I give it 2 bools, like they're any, and it outputs a bool, but like that means I could input a bool as well. So if I put 2 trues in, it's going to output true. If I put 2 falses, that will also be true. If I put true or false, that will be false. And similarly, I can put in strings. So if I say will chill, and then I put a second will chill, that will be true. If I put will chill and ducky, that will be false. The way it works with objects is a little bit different. If I put 2 buttons in, that will actually still be false, because even though they're both buttons, they're not the same button. When it's dealing with objects, they have to refer to the same object, not just the same like type. Moving on, we've got a whole set of chips here: greater than or equal, greater than, less than or equal, and less than. And these all kind of work how you'd expect. They take exactly 2 values, A and B. And if, I should clarify that the inputs are it only supports integers and floats. So the green ones and the blue ones, those are typically just what we use for numbers. So if you give the first port, let's say we give it an integer, the second port will only take an integer. You can't combine integers and floats, but you can give it 2 integers or 2 floats, and it will compare them to see if it meets this inequality condition and return true if it does and false if it doesn't. Some of the most important chips of this bunch here are if and if value, and you'll notice they're kind of similarly named. The main distinction is that if takes so they both take a Boolean input condition, but the if chip takes executions. So you like if you put down a button and you run the orange port on the if, then if the condition is true, then it will run this port out. Otherwise, it will return. It will run the else port out. So that's like if you want to do something, like if the condition is true, do this thing I have hooked up to the then port. Otherwise, run the else chain of execution. If value is similar in that it branches based on the condition, but we're not using executions. We're going to return values. You'll see that instead of having two outputs, we actually have two inputs. Like when we're dealing with values instead of executions, it kind of goes backwards in that sense, where it will look back through the chain of data ports to get the relevant value. So if this is true, it will take whatever value you have hooked into the then port, and it will return it out here. So let's say this is a color, and your condition is, say, I don't know, player is room owner. So for instance, you could say if the player is a room owner, then I don't know, set their name tag to be red, and if they're not room owner, set it to be black. And then you'll take the result. It will automatically pick the correct result and put that out of the chip. Cool. I think that's it for Boolean chips. Any questions?
All right.
Cool.
We can do. Did we put integers and floats together? Yeah, we did. Keep the booleans up there though. All right. Here are all the floats. Ducky, do you want to do it or should I?
Which one do you want to do? Yeah, I can do them. All right. So most of these are pretty common knowledge if you've done like 5th grade math, I'm pretty sure. Yeah, pretty much. But let's go over them real quickly. Absolute value will just always output a positive number, no matter what you input into it. Add, you can configure these four and add more ports, like your bool chips over there, and it'll take all your values and add them together, take all your values, multiply them, all your values subtract, and divide. Remainder will divide it, and it'll take your remainder of that. So, oh yeah, modulo. Oh, what's the difference between those? I don't remember the difference between those. Usually I'm not
The
in
only
data rooms, so I don't
difference
use-
is if they're negative. You probably won't be using negative values on these, so they're identical for positive numbers. Basically, it will, as the name implies on a remainder, it takes the remainder. So if you give it a 5 and then a 2, it will divide 5 by 2. It goes in 2 times, and then you have a remainder of 1 in that case, so it would just return 1. Yeah, I wouldn't worry about the difference between the negatives. Also, absolute value, just to clarify, kind of what it does is it's the distance to the origin. So if you visualize a number line, it's how far your given number is to the origin, which is just 0. So if it's negative, it will return that value except multiplied by -1 to make it positive. So if you have -5, it'll just give you 5. If you give it +5, it'll just give you an unchanged 5.
Power, it'll just multiply itself, your second value times. So if I did like 2 times 2, 4, and then however many times you put it, however many times you want it to multiply by itself. And root, I'm pretty sure that just takes your, in this will just take your value here, and it'll divide it by, it'll take your square root of 2, and, you know, I don't know what you use. I don't really use root, to be honest. But
It's the
just
square root
math
of a
fun-
number, or not?
Yeah,
Square root,
it's
If you
really
give
just,
it 2, it's a square root. If you give it 3, it's a cube root. It's the
yeah,
inverse
it's just
of
the
power.
square root. You want me to do these two?
Yeah, you want me to do them?
I can do them. Clamp, it'll just take your value here, your min and your max, so it won't go lower than your min, and it won't go higher than your max. Max, you can add more ports to these and your min. It'll take your highest value within all these. So gave it 2 and 1, it output 2. And if you added more ports, it just take your highest value. And this is the opposite, it'll output your lowest number. Seal will round upwards, so if you have a decimal number, let's say it'll always round up, even if it's below 0.5. Let's say you had 1.1, it'd be 2. And floor is the opposite, it'll round down no matter what. Round will, obviously say if you're above 0.5, it'll round up. If you're below that, it'll round down. Int to float, it'll literally just convert your int value to a float. You have to do that kind of frequently, depending on what you're doing, but I find I have to convert a lot. Seal to int, it's just this. It's pretty much the same thing, except it converts it to a integer value. And same thing with this. It'll just round down. And since it's a int, it can only be whole numbers. So negative 1, 0, 1. These will just take your min and max and pick a random number between that. Same thing with this. This just goes into decimals, and this doesn't. Pretty self-explanatory, but you'd be surprised.
And the reason we kept out the Boolean, the Boolean chips, is because these chips right here with the white inputs, specifically greater than and less than, greater than, less than, equal to, all of these, they only support the float and integer. It has to be a number. You can't check if two strings are greater than each other. Yeah. All right, so now we're going to go on to an example, something for you guys to see how these chips can go together, and then we'll give you guys something to build. So let me put these away.
You missed one chip. All right.
Okay, so I'm going to go over an example right now. You haven't really learned a lot, so we're going to keep it kind of simple. Just kind of like pure computation, how to set up circuit graphs, how to wire the chips, and how to get values out of them. So we're going to start with a button. A button is pretty much like the simplest place that you can get executions from. As Snug said earlier, all circuit graph execution is the orange port, starts from something called an event receiver. You'll notice you can't see an event receiver here. That's because it's inside the object board. Most of the time when you spawn a button such as a component, any kind of component that gives you an execution, all the important chips are inside of the object board. So if I were to hit edit on this, I'd see chips as we saw on Dootman's screen earlier.
He's showing you right now.
Oh yeah, you can see it on the screen. That's what it looks like inside of it. You'll see right over here, there is a event receiver button pressed. So that's going to run when I hit this. So actually, if you look at the screen, you can see it light up. That little glow to the wire means that the execution port is running. That's actually an extremely useful feature to know how your circuits are actually operating. But anyway, so we hit it, and then this pressed port here is going to run. So what are we going to build here? Let's build something called a Fibonacci number generator. So if you don't know what a Fibonacci sequence is, it's fine. I'll explain it from scratch. So if you've ever seen one of those fancy spirals that you see in, I don't know, fossils or snail shells, it follows the golden ratio. And the golden ratio, it comes up in nature a lot, but it's derived from a sequence called the Fibonacci sequence, which might sound like something maybe you haven't heard before. Maybe it sounds kind of complicated, but in principle, what it is pretty simple. You start with two numbers. You have 1, and then you have another 1. So those are the first two numbers in the sequence. And then if you want to get the next number in the sequence, you just add up the previous two. So 1 plus 1, that's obviously 2. So you have 1, 1, 2. What's the next number? You take the 2, and then the number before that is 1. So 2 plus 1 is 3, and then 3 plus 2 is 5, 5 plus 3 is 8, and so on. The actual mathematics of it isn't too important. I'm just going to show you how to like set up circuits to get something to get something running. So if you get confused about the math part, it's not too important. But anyway, so we want to keep track of the 2 most recent values in this sequence. And how do you keep track of values in circuits? Just like persistently between executions. That's what a variable is for. So let's take out an int variable chip. Since we're going to use integers, you'll notice these are whole numbers, so we don't need floats. We're just going to use ints.
Also, feel free to follow along. You'll have MakerPen.
Also, if anybody has any questions, just stop me. So I'll put down a variable here. You'll notice it's just automatically called int variable2. Something important to know about variables is that any variable that has the same name, if it's not in a circuit board, if it's just like in the same area as another variable, if it has the same name, it will have the same value. So if you change the value from one variable with one name, other variable chips with the same name will also be changed. So we want a second variable, but we don't want it to reference the same value. So I'm going to rename it. I'm going to configure this chip here. I'll configure the first one first, and I'll actually just rename it to, let's see. Let's just name it A. I'm going to hit submit. And then I'm going to do the same thing for the second variable and just name it B. Cool. And I'm going to make these synced as well, so you can see what's going on. So I've made that synced. I'll configure this other one. Also make this one synced. It's just a checkbox. When you configure the variable with your MakerPen, there's a little toggle that says synced. If you turn it on, you'll see this like 2 squares. This just means that if I make a change on my local computer, you'll see the same change as well. It'll have the same value. So how are we going to see this value? Let's use a text component. So text is definitely one of the more useful components in the game. As the name implies, it just shows you text. When you spawn one in, it just comes with a default string, says text, but there is a set text input, which you can just give it any string. So as I said before, a string is just a list of characters. Anything that you can put into text, you can put into a text component. It has a limit of 512 characters, but you probably won't hit that under normal circumstances. So we have numbers. How do we show the number in a text? Because I just said it only takes strings, but an integer is not a string, it's an integer. But one of the most useful chips that we can get is called toString, which does exactly what you'd expect. It takes any value. The input port is of the type any, and it will convert it into a string. So let's take the value and wire that into the toString. So this output port here is the result. It's of the type string already. Let's wire that into the text. So when I run this orange execution port, it'll set this text to anything we have on this port. So if I just disconnect it, if I click and hold with the wire tool on the exec port, it'll actually run it, and you can see it just cleared the text because I don't have any text here, so it just cleared it. So let's wire this back up again, and where are we going to get the value from? Let's just get it from whatever is in value A. We're taking the integer value, we're converting it to a string, we're wiring it into the text component. Okay, that looks good, but we're not actually doing anything yet. When we hit the button, nothing is going to happen. So let's wire this up. First, we're going to take the pressed out of this button port here, and we're going to wire it into the set text. So when we run it, this is going to set this text component to whatever I have in this variable. So something else you can do with variables that we're going to need here is you can set the default value. So I'm going to configure this A variable, and I'm going to set the default to 1. And I'm going to do the same thing on B because the first 2 values of the sequence is just 1. So starting out, they're both going to be 1. So let's see how that works. Let's hit this button and see what happens. Cool. It set the text to 1. It just grabbed 1 out of variable, converted to a string, and set it to the text. So we've already done something that like runs in circuits. That's kind of cool. But now we want it to actually like increment in the sequence. We want it to go up. So currently, if I just keep spamming this, nothing will happen because like these values aren't being changed. They're not being changed in the variables. So let's work on that now. So as I mentioned at the start, the way you get the next value in the Fibonacci sequence is from adding the 2 previous values. So we're going to use an add chip for that. And add chips take integers, takes integers or floats or even vectors, but we're just using integers here. So let's just wire up the two variables. If you look at the output port here, we already have this wired into the toString, but this output port here is how you get the current value of the variable. So if I hover either of these, it'll give me 1. So let's hook these up into add. And since these are both 1 and we're adding them together, it will of course give me 2 on the outputs. Like you can't see it, but I'm hovering over the output. It says 2. So that looks good. So after we run the set text, after we do that, we want to go back and we want to update the values. So next time we run it, it'll have the next element in the sequence. So let's take this exec port here. This is inside the object board, but what happens is we run the set text. There's a chip inside of it to actually set the text. Like that specific chip handles that, and then that internally is routed out to the output set text. So let's take set text. Yeah, you can see it there from on Doom's screen, but let me select this. Okay, let's take the set text output and wire it into variable A. The execution input on the variable is how you set it. When I run this execution into the variable, it will set the value of the variable to whatever I have here. This is just an integer input port. You can see it's defaulting to 0. We don't want to set it to 0, so let's actually like hook something up into that. So let's take the output of the add chip and set it there. So now when I run it, it's going to set the text, and then it's going to take both of these, add them together, and set it back to A. We want B to now be what the previous value was, but we just changed this, so that's kind of tricky. But it turns out we can use a subtract chip and kind of implicitly get that value back. If the math here is like confusing to you, it's not a big deal. It is kind of weird, but mostly we're just looking at how to get like circuit graphs connected and working. So now that we've updated A to be the value of B plus what previously A was, we want to get the previous value of A. So if we take this new sum that we've packed into A and we subtract B, that'll give us exactly what we're looking for. So let's just do A minus B and then wire that into B. So we're going to run it. We're going to update the text. We're going to set A to A plus B. And then we're going to wire this output execution into the input of B. And we're going to set B to the new A minus the current B. Cool. So let's go ahead and run this, see what happens. If I hover over the outputs of these chips, it'll give me a preview of what it'll be when it runs. So add is 2, subtract is 0. Those both look good. So let's hit it once. Cool, looks good. This didn't change because we haven't gone far enough in the sequence yet, but the values, when I hover over it. Oh, that's funny. So this value has changed. The A is telling me it's 16. I assume somebody else named a variable A as well. So that's adjusted my graph because they have the same value. So let's wait. If you have variables named A and B, just like tweak the name slightly so it's not interfering with the example here. Let me set it back real quick. Cool. It looks good. And then if I hit it, this will get incremented. This is now A is now 3, B is 2. If I hit it again, it'll go up to 3, and then 5, and then 8, and 13. And we can just keep doing this like infinitely. Well, not exactly infinitely. Eventually, we'll overflow the 32-bit integer limit, but that's not important. But yeah, we have a functioning Fibonacci generator just with these handful of chips. So as you can see, it might take a second to think about it, like how you want to break down whatever mathematical problem you're solving into the specific set of chips and wires. But once you think about that and you've come to a solution, you can do a lot of different interesting things with just a pretty limited set of tools here. Cool. Any questions on that? We're gonna like break up to work on projects now. So if any time between now and the rest of class you think of a question, just come up and ask me.
All right. So like Will said, we're gonna move on to your own little class, today's class project. And so I'm gonna tell you what you need to make, and I'm not gonna show you how to make it, but obviously if you need help, just feel free to ask and we will give you that help. And to people who are truly clueless, I'll even put what you need up here. But what we want you to make is a button clicker. So you'll click a button, and every time that you click it, it adds 1 to a text. Or even the button itself, you click it and a number counts up. That is it. It is super simple, but we want you to be able to do it on your own. So everyone go find a spot out. There's plenty of spots for everyone. If you need help or a harder challenge, feel free to talk to us.
Snug, can I get a harder challenge?
Cool.
Still involving the.
Gotta make my mic
the-
quieter. Did you make the QR code generator? That's
A
what
clicker,
me
pretty
and
much.
Will
A
always
number
give
that'll count up
QR
whenever you
code.
click a button.
Ducky, mute your
Like,
mic.
you mean like a literal key?
Oh, you mean
okay,
like
okay.
teacher?
Be
Wait,
quiet.
what's the?
Yeah.
How do
It's
I?
left
Wait,
hand.
what is it
Left
again?
hand. Yeah, did you make the QR code generator? That's what
You mean
me
like
and
a
Will
literal
give people
QR
who
code
want
or
a hard
like a
challenge.
code?
Like I give it a
Alright.
link and then
Just make a
it
clicker that'll
generates a
count up
code.
whenever you.
That's what me
Yeah,
and
yeah,
Will
yeah,
You're
give
gonna have to
people
like read
who
like
want a
some
really
white
hard
papers
challenge.
on the algorithm.
You'll have to look up how to do it. You're not gonna just know
I
how.
suspect it's not possible.
I completely forgot how to do this. I so forgot.
But you said you wanted to learn vectors and stuff, and we do have a vector class where we'll go over that. So, but for today, something you can make. You don't know vectors. Oh, actually, I'm assuming you do know vectors at least a little bit, or nah?
I do. I just don't know like the complex stuff, like dotting them, crossing them, everything like that.
Okay. So, can you? Hold on. Let me just look through my thing. Can you make like a gravity gun, like where you point it at someone and then they like float? You know what I mean? Or because that would use vectors. and velocity. So if you don't know that, I'll give you another one.
No, I do. I'll try that. Yeah, it's a good idea.
All right, and make sure you use the networking well. Networking is super
Yeah,
important
I'm not
in a
gonna.
gravity
I'm
gun.
not gonna kill. I'm not gonna kill the frames.
Okay. All right, good luck.
I think at this point you just need to wire things together.
Right. Okay.
Got it? Mhm.
This is pretty much how we expect you to sort them. You know.
Okay.
Also,
I'm gonna guess the remainder
this
chip
the
won't work with this.
with this, it will work, but each color it goes up to 1. So 0 is red and 1 is red. It makes a full loop from 0 to 1. So with the remainder, this will count up 1, and this will output 0.
Right. And then so add one more to that then. Okay. I can, yeah. I'm sorry.
Wonders in here.
You guys made her release it for when it released.
Yo, dude, you gotta take that timer off. Why'd you delete the delay? Did you have it there so you could like reset?
something with this. We're setting this to 1, but we want to set that to our now number that we've mathematically gotten. So our
Like you click it and it adds 1 each time. Only difference is you're not going to need these two. And make sure that you name your variable. Don't make it the default int variable 8. But that should be good.
Hey, dude, man. Can I try to do something that's different? I already know how to make Clicker. Or Snug? Okay, cool. Hey, what's up?
I don't know why I'm changing my controls so much. I'm so goofy. I'm confusing myself. My controls.
Yeah, that's
Yeah,
awesome. I
do
can do
that.
that.
Alright.
Do you want me to do it with players' names or with text?
I would do. Do you know how
Okay.
networking works? Do you know
Networking?
how networking?
Um,
Like synced, unsynced
Synced,
stuff
unsynced?
running
Yeah.
locally and stuff. Like how
Yeah.
stuff will run. Okay.
One with players if it's like
That
not.
that's gonna be super important when you make that color changing beacon.
Oh,
Also,
Mm-hmm. Yeah. Yeah.
uh,
Yeah. Yeah, I got you.
also, do you know what like the time chips are? Like get universal
Yeah,
second.
time to get precise seconds, time get
Okay,
universal
yeah,
seconds, yeah.
you use that for your color changing. Okay, so you
Gotcha.
got it. Can you should I tell people how to sort their circuits, or is that something we should just individually tell people? Because some people got it really rough. Okay. I mean, this is an hour left of class, so we got to think of something else to do. Yeah, I guess. All right. Oh, wait, actually, let me look at the course plan. Uh, do we never go over a list? Yeah, no, we took that out of our agenda. That can be tomorrow. Tomorrow we go over strings, math, and booleans, and we went over booleans and pretty much math. Yeah, it's because for my character thinks that I'm like flying, but for you guys it looks like I'm standing, and so it kind of like bobs. Yeah, like it looks fine for me in third person. I see it bobbing though. Class videos. It's already a channel. Yeah. And I think you're able to message in it. Uh, um, maybe probably just open, but like sort it. You know, how, like on YouTube, you can put like playlists. Put all the videos from this session. Yeah, yeah. Let me make sure that you're able to send messages in there. All right, let me know if you can't, but I think only teachers can send stuff in there. Also, did you do attendance? It's not done. I was vaguely doing it for people I saw, but that is not even close to done. Yeah, I think you should. Or are you asking if you're allowed to? Yeah, just don't touch the names or nothing. That would mess it up. Did I not do that? Oops. Alright, I'll fix it. Alright. Go to just write, it says attendance on Discord. Under class 324, class videos. Do you not see that? Oh, that's weird because there's event invites, class photos, and class videos. There we go. Is there audio? Do you know why there wasn't audio before? Oh. There we go.